Okay, display and calculate multi-step event probabilities. So this is 8F. Alright, so what does all that mean? So multi-step events are, unsurprisingly, where multiple things need to happen one after another. Now it might be just 2 things, it might be 27 things, whatever it is, it's just more than one thing happens. So if I'm rolling a 1d6, that's it, it's one event. I get a 1, 2, 3, 4, 5 or 6, that's it. However, if I roll 2d6, I can think of that as rolling 1d6 twice. So that would be a multi-step event. Okay, so got some examples to go. There's a 30% chance of rain today, and there's a 60% chance of rain tomorrow. And we're going to assume that if it rains today, it doesn't affect rain tomorrow, which may or may not be valid, but it's my example, so I'll do what I want. Okay, what's the chance of 2 wet days, 2 dry days, 1 wet day over the next 2 days? Okay, well, usually a good idea is whenever anything gets mildly complicated, draw something to help you think. So what we're going to draw is what's called a tree diagram. Now why is it called a tree diagram? Because it kind of badly looks like a tree on the side. So let's go with, what happens before everything else? We exist. So we exist, I highly recommend, is a dot. Before you do anything else, you should start with a dot, just to have a starting point. Okay, great. So there's a 30% chance of rain today. Okay, so the first thing that has to happen is today. What can happen today? It's either going to rain or it's not. So there's only 2 options. So from here I'm going to branch. There are 2 options. It either rains today or it's dry today. I could do R prime, but that's going to get a bit old, and if I have to say R prime, it's going to get really weird, so R and D. Cool, so it rains or it doesn't rain. Great. Alright. So that's today, which I'll just put up here as a little note. Don't have to do that, but sometimes it helps. Great, today is done. Cool, what happens next? Well, tomorrow would happen next, unsurprisingly. Cool, what happens tomorrow? Well, it either rains or it doesn't. So from here, if it rained today, then tomorrow happens, and either it rains or it doesn't. Cool, and similar story, if it doesn't rain today, well, tomorrow's still going to happen, and it will either rain or it won't. Great, so this is tomorrow. Cool. Alright, well, that's that. What are we going to do now? Well, we need to use these percentages, or these probabilities, I should say. Okay, well, here's us existing at the start of today. Alright, what's the probability we end up at rain today? Well, rain today was 30% chance, so we'll put this as 0.3. Okay, I'll put the 0.3 just to make that abundantly clear. So 0.3, same as 30%. Cool, okay, well, if it's 30% chance of rain today, that implies that it's 70% chance of no rain today. Cool, alright. We now move to tomorrow. What's happening tomorrow? There's a 60% chance of rain. Okay, so that's going to be 0.6 because that's going to rain. This is going to rain, so that's 0.6. Okay, great. Well, that implies 40% to not rain. Cool. I should write that a little bit better. That's a bit better. Okay. Beautiful. Okay, great. Well, now I've got a nice diagram, but how do I even read this thing? So, when we're reading these, we read along one of the entire stems. So, if I go along this way, I'd go rain and then rain again. So, rain and rain again. Okay, I want to know the probability. No, I probably shouldn't put equals, put colon. So, rain and rain again means that both of these happened. And when we're doing this, and in probability means multiply. So I need 0.3 times 0.6, so 0.3 times 0.6 gives me 0.18. Beautiful. So the probability that it rains 2 days in a row is 0.18. Cool, so I can put that up here as 0.18, or 18%, whatever you want. Cool, okay. Here would be RD, here would be DR, here would be DD. Cool, the next one I asked for was 2 dry days, so I'll go with that one next. Well, that's 0.7 and 0.4. Great, which gives me 0.28. 0.28. Great. Okay. One wet day. Well, I could go this way, which would give me 0.3 by 0.4, gives me 0.12, or I could have gone this way. 0.7 by 0.6, gives, yeah, one wet day, yeah. 0.42. Okay, well hang on, which way do I go though? Well, I could go this way or this way. So what I want is this or this. So I'm going to add those because or in probability is add. So I get 0.54. Cool. Okay. Great. Now, how do we know if this is right? Well, hang on. It's got one other option, which I might as well. I don't know, does it? That's it. So, 2 wet days, 2 dry days, 1 wet day. Is there any other option? Well, no, because I have to have something happen on each day. So, double wet, double dry, or one of each. There's no other option. I can't have none of one of them. I can't have none happening on either day. So that has to be all the totals. So that has to be everything. So if I add this up, what do I get? I get 0, carrier 2, gives me a 0, carrier 1. Cool, I end up with 1. Does that make sense? Well, yeah, everything added up should add up to a probability of 1. Cool. Next scenario. Bag of marbles, which is overly used, but it's a goodie, so let's use it. We've got 5 reds in there, 3 blues, 2 greens. So it's in a bag, can't see what's in the bag. I'm going to pick out 3 at random. What's the probability that I get 1 of each, so an even distribution? Okay, well, there's a lot going on here. I've got to pick 3 out at once. Oh, hang on, but this only lets me pick out 1. But is this any different to me just picking out 1, and then another one, and then another one? If I pick them all out at the same time or one at a time, does it make any difference? No, I'm just making that choice, so it makes no difference. That's fine. So, I can think of this as picking them out one at a time, which makes it a lot easier. So, first thing we're going to do. Dot for we exist. Okay, well, this thing might get a bit complicated because we're picking 3 things. What can happen? Well, potentially, at least in the first branch, we've got 3 options. So I've got 3 branching, and then 3 branching, and then we'll assume for now 3 branching. So that'd be 3 by 3 by 3 is 27 sets. This thing might get a little bit big. Okay, so I should plan ahead and try to count this out. So section, section, section. 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15, 16. Okay, 17, 18. Which is going to be too big still. 19, 20, 21, 22, 23, 24, 25, and I'll get rid of that one because I know that I won't need it. So, in theory, if you were doing this, you'd do 27, but I'm going to hopefully be a little bit smarter. Do some of my branches, about there. Okay. So, I'll go, yeah, that's alright. Cool, so about there. Yeah, I'm going to have to do that. Move 1 dot up. Congratulations, Dot, you got promoted. Oh, knees. Ooh, that was wobbly. What have I got? 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, this is going to go to. I'm going to have to move him up. So that makes more sense in a second. Oh, knees. There. Now you can do this blind, but you're basically asking for trouble. nice and straight. And green again. Okay. Okay, so I've got a whole lot of things going on. Okay, we exist. What can happen? I pick my first marble. So I've got red, blue, or green. Beautiful, okay. What can happen after that? Let's say I pick red first. Well, I could pick more reds, blue, or a green. Now you can change the order if you want, but you're almost certainly going to confuse yourself if you do that. Don't do that. One thing at a time. Cool, I've picked 2 reds. Okay, can I pick more reds? Yep, that's fine. Can I pick more blues and greens? Yep, that's fine too. Cool, in fact I'm going to put these after, because otherwise it's going to get a little bit difficult to read. Red, blue, green, red, blue, green, red, blue, green, red, how many have I got? Yep, blue, green, this is red, blue, green, oh, red, blue, green, red, blue, green, red. Now, what we'll notice is, hang on, I've missed one for green, but if I go 2 greens, can I get a third possible green? No, I've only got 2 greens. And you should think through the rest of them, but it turns out that that's all good. Okie dokie. Now we've got to sub in some numbers for things. Okay. Well, what's the probability that I get red first? Well, that's 5 out of the 10. So 0.5. In fact, do I want to make this? I'll make these all fractions because otherwise the decimals are going to get too long. 5 out of 10. Now I could change that to a half, and that's totally fine. You can do that if you want. If you start simplifying on just your base diagram, things are going to get really complicated really fast because you're going to have a whole lot of different denominators. So I recommend, for just the working, you leave things in the same denominator as much as you can, just because it's easier to add those. And you only have to figure out the multiplications once, and you already know what the result is. Okay. Blues, there are 3 out of 10. Greens, there are 2 out of 10. Cool. Check that it adds up. 5, 3, and 2 is 10. Makes it easy to check if they're all the same denominator. Okay, what if I had red, then another red? Alright, well, one's already gone, so there's only 4 left. So that's 4 out of 9, because one of them's already gone. Cool, okay. Blue, similar story. I've got 3 out of 9 left. And green, 2 out of 9. Beautiful. Now we can go through filling all these out, which will take absolutely forever. This is 5 out of 9 now because the blue got taken, so there's still 5 reds out of 9 remaining. Similar story, that's 5 out of 9. If we're going along here, well, 2 reds have come out, so I've only got 3 reds left. 2 have come out, so there's 8 in total left. Cool, along here, 1 red's come out, so I've only got 4 out of 8. 1 red's come out, so 4 out of 8. And similar story for the rest. This is 4 out of 8. What's this? Blue, I should fill that in. So that's 2 out of 10. This is 3 out of 10, out of 9. Whoops. Cool. Green, still 2 out of 9. 1's come out, so 1 out of 9. Each subsection should add up. So 4, 3, and 2 makes 9 out of 9. Yep. 5, 2, and 2 makes 9. Yep. 5, 3, and 1 makes 9. Yep, that's fine. And we can go through adding all these in. 5 out of 8. 5 out of 8. 4 out of 8. 5 out of 8. 5 out of 8. Cool. And we can go through filling out the rest of it. Now, what we were interested in is what's the probability of getting 1 each? Alright, well, there's several ways I could do that. I could get red, blue, green, or I could get red, green, blue, or blue, red, green, so on, so on, so on, so on, so on. Alright, so what I recommend at this point is pick a different colour. Or if you're working all in the same colour, fine, you can be monochromatic. Red, that's no good to me. So red, blue, yep. Well, then I need green, so I need that one. Red, green, then I would need blue. Blue, red, then I would need green. Blue, blue is no good. Blue, green, then I would need red. Green, red, blue. Green, blue, red. Green, green is no good. Cool. So I've got 6 different options there. With a little bit of permutation theory, you can figure out, combination theory that is. You can figure out how many you should get, but go through, double check with yourself, and it's all good. Okay, well, I need this branch. Okay, well, that's 2 out of 8 on that one. So here I've got 5 by 3 by 2 all over 10 by 9 by 8. Cool. Alright, what about the next branch? Well, the next branch has 5 by 2 by, oops, I haven't filled that in, 3. 5, oh no, by 2, oh, of course that's the colour I need, by 3, all over 10 by 9 by 8. Cool, next branch, what's that green there, is 2 out of 8. So we've got blue is 3, 5, and 2. 10 by 9 by 8. And hopefully a pattern's starting to emerge. If you haven't seen it already, definitely start looking for it. 5 out of 10, 9, 8. This is 3 out of 8. So what colour do we start with? Green. 2 by 5 by 3. And last 2 by 3 by 5. Cool, alright, great, so we filled all that out. Well, hopefully, early on you would have noticed that there's a definite pattern going on here. Well, hang on, they've all got 2, 3 and 5 on the numerator and 8, 9, 10 on the denominator. Well, this is the good thing about keeping everything in the same denominator for everything. You end up seeing a lot more patterns. So, hang on, if I change the order of multiplication, does that change anything? No, that doesn't change anything at all. So, essentially what I've got is 5 by 3 by 2 over 10 by 9 by 8, and I've got 6 of those, so I've got this outcome, or this outcome, or this outcome, or this da-da-da-da-da. So I've got that plus that plus that plus that, but that's, all of them are the same, and there's 6 of them. So multiply that by 6. Put it there. Cool, alright, well, I could type that into a calculator, but if we're feeling a little bit smarter, we can go, well, hang on, I don't even want to waste the time to pick up a calculator and type, because I can go 5 and 2 makes 10. Cool. I've got this 6, I can break up into a 3 and a 2. 3 and 3 gets rid of the 9. Cool. I've got, so that 6 is now gone into those. So I've got 2 over 8, quarter, done. So probability of getting one of each turns out to be a quarter. Isn't that nice? Now, this is a particularly large tree. If you were doing things that get pretty much beyond about 12, it's pretty much as big as you want to draw. You can usually think about it in a smarter way. However, sometimes you'll just be so confused by the thing that it actually is faster to draw it out. But largely, if you go beyond about 30, you're really going to struggle to fit that on one sheet of paper. So you can draw it over 2 if you want, but the more pieces of paper you've got, the more likely you are to confuse yourself or do something silly. For most of the things that are actually in the textbook, it'll be dramatically smaller. A lot of them will just be these 2 2s. Some of them will be 2 sets of 3 or 3 sets of 2, things like that. 3 sets of 3 is about as big as you'll probably see for a while. That's it. The other thing that we should be checking the other thing that we should note as well is a lot of the time you don't have to fill them all in. You can do that ahead of time and just double check that everything groups correctly. But that's another way to save time. Alternately, another thing you could do is just draw this out, and instead of drawing this whole thing out, is just write out the combinations that satisfy this condition and then work those probabilities individually. We'll do a little bit more of that later, where there's the actual tree is more than 100 size, so you could not feasibly draw the whole thing, so you have to start working smarter. For now, you can draw the whole thing, and it's usually good practice because then you can imagine it for the 100 big thing without actually having to do it all. Cool, that's ADF. If you get stuck at all, do send me an email. Otherwise, cheerio.